Hi, in this video, I would like to present about chapter 10, which is carboxylic acid and its derivative. My name is Muhammad Hafiz Farhan bin Ismail from KT24. The general formula of carboxylic acid is CnH2nO2. Carboxylic acid has divided to two classes, which is aliphatic and aromatic. Aliphatic is an alkyl group bonded to carboxyl group, for example propanoic acid. Aromatic is an aryl group bonded to carboxyl group, for example benzoic acid. If you want to naming this functional group, first of all, you must replace the E letter in the alkene with oic acid. Second, number the carbon chain starting with the carboxyl C atom. And the last one, the carboxyl group takes priority over any functional group. For example, methanoic acid and ethanoic acid. Physical properties for lower aliphatic is colorless liquid at room temperature. Benzoic acid is solid white with melting point 121 degrees Celsius. Boiling point for carboxyl group is higher than alcohol, ketone or aldehyde of similar molecular weight. This is because carboxylic acid is more polar. It forms a stable hydrogen bonded dimer. Molecules in dimer is closer and the hydrogen bond is relatively strong. High energy is needed to break the bond. Solubility for aliphatic is soluble in water because they form many hydrogen bonds in water. Solubility in water decreases as length of the carbon chains increase. Solubility of aromatic is slightly soluble in water due to huge aromatic ring. For benzoic acid, they forms dimer in non-polar solvent. There are 4 ways to prepare carboxylic acid, but first of all, we must know the common oxidizing agent, which are warm acidific potassium permanganate and warm acidific potassium or sodium dichromate 6. There are 8 reactions of carboxylic acid. The reaction that involves the donation of hydrogen from hydroxyl group is neutralization. Carboxylic acid are acidic. It can react with base such as natrium hydroxide to give metal carboxylate salt. The second is reaction with reactive metal such as natrium, kalium, calcium, magnesium and ferrum. The reaction that involves the substitution of hydroxyl group to form its derivative is alkyl chloride formation. Acid chloride can be prepared from the reaction of carboxylic acid with tritonic chloride, which is SOCl2, phosphorus pentachloride PCl5, or phosphorus trichloride, which is PCl3. Esterification. Carboxylic acid react with alcohols in the presence of mineral acid catalyzed to produce ester. Acid anhydride formation. Acid anhydrides can be prepared from carboxylic acid by the elimination of water through heating. Amides formation. This is a reaction of carboxylic acid with an ammonia or amine to produce amide. The reaction that involves the reduction of carboxylic acid to primary alcohol is reduction. Carboxylic acid are reduced to primary alcohols by reacting with reducing agents such as lithium aluminum hydride and sodium borohydride. The last reaction is oxidation of methanoic acid. Methanoic acid molecules has both carboxyl and carbonyl group. It shows the properties of both carboxylic acid and aldehydes. It also shows reducing properties in reaction with acidific KMnO4 or K2Cr2O7 and Tollens reagent. The application of carboxylic acid. The first is polyamide, which is nylon that used in making carpet and apparel. Second is ester that used in artificial flavors. The third is acetic acid that used in making the vinegar, ethanoic anhydride in making drug aspirin, and the last one is salicylic acid that used in analgesic. That's all for me.